Now, this video discusses about the trigonometry part 2, where I'll be discussing about the sine law, cosine law, as well as the area law. And of course, in the actually preceding videos, we'll be discussing about the applications of the actually cosine law as well as the sine law in the context known as actually the bearing. So let's start it up. We have several types of triangles. We have what we call as the right-angled triangle. We have what we call as the right-angled triangle. So a right-angled triangle, it is the triangle whose one of its internal angles is actually a 90 degree. So a right-angled triangle looks like this. So a right-angled triangle, looks something like this. And in that case, one of its internal angles is 90 degrees. So let's say this is the triangle A, B, and let's say C, like that. And in that case, this is said to be a base, and this is said to be the height, and this is said to be the hypotenuse, like that. And how are the sides of the right-angled triangle are related? And let's say this is the side BC, that is opposite to angle actually A. I'll call it as the side labeled small letter A. Likewise, the side which is opposite to angle B and which is said to be the hypotenuse, let me call it as the small letter B. And also likewise the side AB, I should have it as C. Now, let me take it a bit. Let me take it back. How are the sides of the right-angled triangle are related? Now, the sides of the right-angled triangle are related by a theory known as the Pythagoras theorem. According to the principles behind the Pythagoras theorem, it states that square of the base, which is a square, and plus the square the height, which is c square, is the same as the hypotenuse square. So this is what we call as the Pythagoras theorem. So more about the Pythagoras theorem, just have to refer to my video playlist on the YouTube channel as well as the TikTok. You come across all these things as you actually expect. And now, how about the area of a right-angled triangle? How the area of the right-angled triangle can be expressed? Now, the area, this is only being applied for the right-angled triangles. So the area is given as the half base, which is A, and it times the height, which is C. And the units for area, are given as meter square. It can be given in centimeter square, and also even the millimeter square. It depends on the units that are being given, but the area for right-angled triangle is given as half base square. It should be half base times height. So this is how you should have to understand that one. So Pythagoras theorem is also being only applied for the actual right-angled triangles as well. And apart from the use of the Pythagoras theorem and also the area for calculating and also the formula for calculating the area of right-angled triangle, the internal angles of right-angled triangle and also the sides are actually expressed by what we call as the trigonometric part 1. So part 1, we discussed about the concept of the SOHCAHTOA. So you should have to know about the SOHCAHTOA by now. So what we call as the SOHCAHTOA, where actually this represents the sine of the angle, opposite, hypotenuse. This is the cosine of an angle, adjacent, hypotenuse, tan of the angle, opposite, adjacent. Let me just have to express back as well, and for you to have a hint on this. So keep in mind that apart from the use of the Pythagoras theorem, to express the relationship among the sides of the right angle triangle, and also apart from the use of the area, which is this formula to have the area of a right angle triangle, we can also be able to analyze the angles and also the sides of the right angle triangle using trigonometry, part 1, and which is more concept of the SOHCAHTOA. Now let me use the same triangle, and this is just a part of a review that you should have to keep in mind about. This is angle A, and this should be angle given as C. So in the trigonometry part 1, we discussed about what we call as SOHCAHTOA. We discussed about what we call as the SOHCAHTOA. So in this case, let's pay attention on the angle labeled C. So how the angle labeled C is related to the sides of the triangle. So in this case, you can see that for angle C, this is its opposite side, and this is its adjacent side. So if that is the case, opposite and adjacent, we are talking about the TOA, of which T is the tan of angle C, and which is equal to opposite, which is A, should be which is C, and divide by A. So this is how we can express it. And likewise, with the respect to side, side B, that is hypotenuse. So we have the adjacent and the versus the hypotenuse. And what is that one? So in that case, we'll have it as this, and that is cos of angle C, and which is given as the adjacent, that is A divided by B. So this is how we can have it. And likewise, this is the opposite and this is the hypotenuse. Now how should we have that relationship? So opposite hypotenuse, that is so which means we'll have a sine of angle C, and which is equal to opposite divided by hypotenuse. Now this is how you should have to understand about something like that. And also for the other angles, this is now a task for you. Express the trigonometric ratios associated with should be angle A, like that. Let me just have it as what is the value of the sine angle A. So the expression for the sine of angle A, and the sine is more of the opposite as well as the hypotenuse. Now for angle A, this is the opposite, which is A. So half A divided by the hypotenuse, which is B. And how about the tan of angle A? So the tan of the angle A, which is opposite adjacent, so in this case we'll have it as A divided by, and this is its adjacent side, so have it as C. And how about the value of, expression for the cosine of angle C? So in that case, that should be cosine of angle A. In that case, we'll have it as, on the cosine, we have the adjacent hypotenuse, which is C over B. So this is how you should have to understand about the trigonometric ratios and how to do with the right angle triangles. So right angle triangles can be actually analyzed using the Pythagoras theorem, using area of the right angle triangle, and also the trigonometric ratios. That is a trigonometry part 1, and that you cover in form 3, as you can remember. So now a question for you, and that's the point of interest in this video. How about if we have a non-right angle triangle? If we say a non-right angle triangle is the triangle whose one of its actually it is the triangle whose none of its interangles is 90 degrees. So we have the other types of the triangles like isosceles triangle. So isosceles triangle, it is the triangle with two sides being the same. So isosceles triangle, it is the triangle whose two sides are the same. Let's say this is the triangle A, B, and C. Now, assuming that this is the isosceles triangle, and let's say the side AC is the same as the side AB. If that is the case, then the base angles are also the same. So this is what we call as the isosceles triangle. So if this is the case, should we say the sides of this triangle will also be expressed in the same way we discussed about the ladder-angled triangle? Should we have to apply the Pythagoras theorem here? Should we have to apply the area that we use to find the area of a ladder-angled triangle? And should we think about the trigonometric ratios, that is about the SOHCAHTOA on the isosceles triangle? And obviously no, because this is non-angled triangle, and none of its internal angles is 90 degrees. So forget about that. And we also have the another triangle, which is equilateral triangle. So equilateral triangle, all sides are the same. So it is the triangle in which all sides are the same. So in that case, it is the triangle in which all sides are the same. So in that case, we'll have, let's say, this is the side which is the same as this, and also which is the same as this. And let's say this is the triangle ABC, like that. And since the sides are the same, it means the internal angles are also the same. And basically, they're all given at 60 degrees. So this is 60 degrees, and also this one as well as this one as well. So that's about the equilateral triangle. And should we say that we can actually analyze the triangle using the same way we discussed about the ladder-angled triangle? Obviously no, because this is no longer ladder-angled triangle, and none of its internal angles is 90 degrees. So forget about that. And that is for any actual triangle, for any non-ladder-angled triangle, cannot be analyzed using the Pythagoras theorem, using the trigonometric ratios. And what do you think we can have to analyze such kind of triangles? So here is the solution for that. That is a trigonometry part 2. That is a trigonometry part 2. That is a trigonometry actually part 2, and which is basically in form 4. So trigonometry part 2, where I will be discussing about the sine law, where I'll be discussing about the sine law, and I'll be talking about the cosine law. We'll be talking about the cosine law, and I'll also be talking about what we call as the area law. And finally, in the next videos, we'll be talking about the applications of the trig part 2. So applications, and basically much of it is about bearing concept. So we'll be talking about the bearing, and also sort of the angle of elevation, just part of things, angle of elevation, and also the angle of depression. So we'll be talking about the few part of the angle of elevation and depression. But our main point of interest in the applications, we'll be talking about much on the bearing. So which means for you to understand about the bearing concept that we'll be discussing later, you should have to pay much attention on the concept of the cosine law as well as the sine law, because that will be the basis. So trigonometry, actually a part 2, it works as the alternative for actually Pythagoras theorem and also the trigonometry part 1. What you have to understand is that if we have non-ladder-angled triangle, the analysis of the non-ladder-angled triangle has to be done using the trigonometry part 2, of which the likes of cosine law, sine law, as well as the area law, of which Pythagoras theorem can't work. So it is like the alternative for Pythagoras theorem. So where Pythagoras theorem can't work, we'll be applying the trigonometry actually a part 2, where we'll be able to working on the non-ladder, where we'll be working on actually non-right angled triangles. So let's see, I start it up. Let's say we have non-right angled triangle. Let's say we have non-right angled triangle. Let me have it in this way. Match, I should push it this. And let's say this is the triangle, which is given as the triangle. It is the triangle A. It is the triangle ABC. Let's say this is the case. And assuming that these angles are different. Let's say that is the case. So let's think of how we can label the sides of this triangle. So we have the side BC, and which is opposite to the angle A. If that is the case, then we'll label this one as a small letter A, corresponding to its opposite angle. And likewise, this is side B, and this is side C. We'll have that. So let's see how we can apply the cosine law in this case. So how should we have to apply the relationship exist among the sides of this triangle, which is non-right angled, and also the internal angles? Now, if that is the case, then the sine law states that, in this case, let's start with the angle A versus its corresponding side. So according to the principles behind the sine law, it states that, the ratio of the side A to its actually opposite angle, and to the sine of its opposite angle is the same as the ratio of the side B to the sine of its opposite angle B. It is also the same as the ratio of the side C, to the sine of its opposite angle. So this is what equates as actually a sine law. And now, how about the cosine law? Now, the cosine law states that, let's say we have an interest. Let's say we have an interest to have the value of the side A. So if that is the case, then according to the cosine law, it states that the side A square, it is the same as, the square. It is the same as the summation of the square. It is the same as the square summation of the other two sides, and that would be given as, B square plus C square and minus 2BC times the cosine of the angle which is opposite to side A, which is angle A. And also, if we would like to have, let's say, the side B, then the formula will be given as B square is equal to the other sides, that is A square, and plus C square, and minus 2AC times the cos of the angle which is opposite to side B, which is angle B. And also in the same case, if we have an interest with the side C, it means we'll have C square, which is equal to the other sides, will have it as A square plus B square minus 2AB, times the cos of, and that should be angle C. So this is what equates as, the cosine law, as you can see. So if we have an interest to have, let's say, the value of the side A, and also even if we have an interest to have the value of the angle A, it means according to the cosine law, then we'll have it as A square. And in this case, we'll have the sum of the squares of the other two sides apart from this, and the minus 2 times, now we'll have the product of the sides that has been expressed here, in times the cos of the angle which is opposite to this one, likewise as we have expressed there. So keep that in mind. And how about the area law? So the area law states that the area of this triangle can be given as, half. Now half times Now let's say we are to use the angle B. So what are the sides that has formed the angle B? You know, the angle B has formed by these two sides. So we'll have it as half times C, A times C, and the sine of the angle B. We'll have that. And likewise, if we are to use this angle, what are the sides that has formed this angle C? So the sides are B as well as the A. So have it as half times B times A times the sine of the angle, which is C. And let's say if we are to use this angle, what are the sides that has formed that angle? We'll have it as A is equal to half times, a B times C times the sine of angle B. Should be angle A. So that's the principle behind, the area rule. And mind you, these are only applied for the non-right angled triangles. So let us see how we can apply those in the following questions and appreciate. Let's say we have the triangle. Let's say we have the triangle, which is given as, let's say this is angle 49 degrees. Let's say this is side A, this is side B. Let me just have to use another notation. Let's say this is side M and this is the side A, and I should say this is the angle MA, and let's say we have B, and this is 49 degrees, and we have, let's say this is 6 meters, and let's say this is, I should have it as 7 meters. Now in this case, what is the area of this actually triangle? Now the area of the triangle will be expressed using the area rule, of which if we tend to label the sides, this is the side M and this is the side P and this is the side labeled A, like that. And we understand that the area of the side, actually in the area of the non-angled triangle, is expressed using what we call as the area rule. So we are being given the angle which is 49. So are we being given the sides that has formed that angle? And obviously yes, we have the side A and also the side P. So we are safe to use the area rule. So we are safe to apply the area rule in that case. So it means we have half times N times P times the sine of the angle, which is 49. Should be times the sine of the angle M, like that. And we have half, and what is the side N? We have it as 7 meters. And what is the side P? We have it as 6 meters. And we have the sine of 49 degrees. So how should you have the area there? So in that case, we'll have it as, we'll have it as 7 times 36, and it times the sine of, that has to be times the sine of 49. Overall it is given as, should be 31.7 meters square. So this is the area of the triangle. So keep that in mind. Now how about the value of, let's say, the side M, if that is the case? How should you have the value of the side M, or it should be the value of the side PN if this is the case? Now there is one thing you should have to understand about actually a cosine law. Now the cosine law is applied. Let's say we are looking for the value of the side M, and there are two things you have to understand. First thing, the angle opposite to that side must be given, and also the other two sides must be given. So as you can see here, we are to calculate the value of the side M, and the angle opposite to that one has been given, and also the other two sides have been given. Therefore, we are to use the cosine law. So in that case, we'll have m squared, which is equal to n squared plus p squared, and the minus 2np times the cos of angle m. That is, so in that case, we'll have m squared, and which is equal to, so what is the value of n? We have it as 7. So have 7 to the power 2, and the plus p, which is 6 to the power 2, minus 2 times 7 times 6 times the cos of, angle 49. We'll have it as that. So we have it as 49, that is the m squared. We have it as the 49 plus, 36, and the minus. So we'll have, 7 times, should be 2 times, 2 times 7 and times 6. And also times the cosine of, and that should be 49. So that is being given as the negative, that should be 55.12. And what is the sum of 49 and plus 36? And that is 85 minus, should be, let me take it back, 49 plus 36, that is 85. So we have 85, and the minus 55.12 should be 0.12, and which is 55 point, 0.12, that is 29. So we have 29.88. We have m squared. Then we're solving for m, we'll have it as m being given as, so what is the square root of that one? So we have it as a 5.47 meters. So that is the value of the side railroad m. So it is given as, a 5.47 meters. So we'll have that. Now how about the values of the other actually two internal angles? And that is, we mean, this angle as well as the angle. So how should you have it? Now, as you can see, we have actually all the sides of the actually triangle, and also we have one internal angle which is 49. Then I think we can use the actually a sine law. So according to the principles behind the sine law, have any over sine of, should be angle n, which is equal to m over sine of angle m, which is equal to p over sine of angle p. I think we can have that like that. And we have n. What is the n? We have it as 7 meters divided by, and we do not have the angle actually n, so just have it as a sine n. Now, which is equal to, what is the value of the side m? That is 4.47 meters, and divided by, we have it as a sine which is 49 degrees, and which is equal to, what is the side p? We have it as 6 meters, and divided by, and we do not have the value of the angle actually p, so have it as the sine p. Using these two actually things, we can be able to have the value of the angle p. So let's just have to extract that part. So let's think of cross multiplying. Cross multiplication, we have 6 times, sine 49. So we'll have it as, 4.53, and which is equal to, and sine p times this, that will be given as, 5.47, times the sine p. Let me just have this like that, times the sine p. So like that. Then we'll cross multiply. We'll divide both sides by 5.47. So that is have a sine of angle P that will be equal to 4.53, divided by 5.47, like that. So have sine P, that will be given as, let's now have, the division of those, 5.47, that should be 0.47, by the way. That is 0.8 to, let's say 8, like that. And we'd like to have the angle P. So what is the value of the angle P? Now the angle P will be given as the sine inverse of 0.828. So in that case, that angle P, is given as 5.9 degrees. So that is the value of the angle P. And now we have the value of the angle P. We can now be able to have the value of the angle N using the angle sum of triangle theorem, and which states that the angle P plus angle M, plus angle actually N is the same as 180 degrees. So in this case, we have the angle P, which is the one we have already calculated, given as 55 point, and that should be 9, and the plus angle M, which is given as the 49 degrees, and the plus angle N, that is to be calculated, is equal to 180. So sum this, you transfer that to that side, and so for that. So that will be the way you can have it there. How about, let's say, if we have this kind of a case. Let's say we have, something like this. Let's say we have, this is a triangle X, Y, and let's say Z, like that. And let's say we have, this is, and that should be, this is 10 meters. Let's say this is 20 meters. And let's say this is, it should be 30 meters. Now the point of interest is that we should calculate the values of the internal angles, and also should be the area of the triangle as well. Now first thing, we should calculate the sides, actually the angles of the triangle. So mind you, this is non-right-angled triangle. So in this case, let's have an interest to have the value of the side Q, that is angle should be. Let's have an interest to have the value of the side of angle X. So now if we are to find the value of the angle X, we have the opposite side, we have its opposite side, which is 20 meters, and we have the other actually two sides. Then we can apply the cosine law. So in this case, let me label the sides. This will be given as X, this is Z, and this is Y. So since we are looking for the value of the angle X using the cosine law, then we'll have to express the cosine law where X will be the subject. So in that case, we'll have it as X squared, which is equal to Y squared plus Z squared minus 2xz, and the times the cosine of should be angle X. Now what is the X? We have it as 20. We'll have to the power 2, which is equal to, what is the Y? We have it as 10 to the power 2. The plus, what is the Z? We have it as 30 to the power 2 minus 2 times 10, and the times 30, and the times the cos of X we are looking for. So what is it? 20 to the power 2? That is 20 to the power 2. That is 400. So have 400 here. That is, we have 10 plus, what is 30 to the power 2? So that is 900. So have 900 minus So what is that one? We have 300 times 2, that is 600, and cos of x, like that. So what is the sum of this? We have it as 1000. So have 400 is equal to 1000 minus 600 cos of x. So transfer this to that, that will be given as 400 minus 1000, which is equal to negative 600 cos of angle x. So that is given as the negative, and that should be 600. Should be that negative 600, that which is equal to negative 600, and the cos of angle x. So in that case, you divide both sides by negative 600. In that way, we'll have it as, cos x, being given as, should be given as the 1. So in that case, we'll have x, angle x, being given as the cos inverse of 1. What is the cos inverse of 1? So what is the cos inverse of 1? And basically, by the way, it is given as L. So cos inverse of x should be cos inverse of 1 is given as L degrees. By the way, but this is the principle behind, only that, there was an error in labeling the sides of the triangle, but that is the principle behind. This is how we calculate it, only that it was not supposed to be something like 0. No, it was supposed to give a certain value apart from 0. But anyway, keep it cool. But that's how we can have it. And now let's say this is given as 0 degrees. Then which means we can be able to find the values of the other angles, which is this and also this one, using the same way we discussed before. So try to have this angle as this angle. And then afterwards, you should have to calculate the value of the area of the triangle. So try that. Now let's say we have this triangle. Let's say this is the triangle. Let's say we have the triangle. This is A, B, and let's say C. And this is angle 42 degrees. And we have this is 4 centimeter. And let's say this is 5 centimeter. So we'd like to, complete the triangle. We should have to solve for the triangle and also find the area of the triangle as well. So if we're saying solving the triangle, it means we should find anything concerning the triangle. We should have this side, this angle, and also this angle. And at the same time, we need to find the area of the triangle. So let's proceed. So in this case, this is the side C, this is the side A, and this is the side B. So we have, we have the angle B with its opposite side, which is 4 centimeter. And we have the side actually A, and its opposite angle is not being given. So if that is the case, then we can be able to use the cosine law in order to have this angle. So what is the cosine law? Actually, what is the sine? We can have to use the sine law in order to have. So that is, we can use the sine law in order to have the value of this angle. Since we have this angle in the opposite side, and we have this side, and we need to have this angle. So what is the actually sine we can have to apply? So in this case, we'll have A divided by sine of angle A, which is equal to B divided by the sine of angle B, which is equal to C divided by the sine of angle C. So what is the value of the side here? We have it as 5 centimeter divided by, sine of angle A, which is equal to, what is the side B? We have it as the 4 centimeter. They divide by the sine of angle actually B, which is equal to, side C is not yet being there, so just leave it in that way, and I divide by the sine of what is the value of the angle C. It is not there. So using these two things, we can be able to have the value of the actually angle A. So upon having, so by the way, we have angle B, which is for 2. We have angle B, which is for the 2. So it means we'll have the value of the side, actually angle A, using the information. Then from there, upon having the value of the angle A, then we can be able to have the value of the angle C using angle sum of the triangle. Since we have the two angles, we'll have it here. Then we'll be able to solve the value of the side C. And also from there, I can be able to have the area of the triangle, either by using this angle and these two sides, or this triangle using these two sides, or this angle using these two sides. Whatever the way, it will be just that. And let's say if we have this case, and appreciate how we can, and say have it there. And how do you think this one can be done if that is the case? Let's say if we have this kind of a triangle, so you should be very well oriented in these things, because you'll be in need of this, and for the time being, basically in the context of the bearing. So you need to apply this as well. We have, this is a triangle, y, q should be r, and let's say this is we have the angle which is 71. Let's say this is 71 degrees, and then we have, let's say this is 43 degrees. So we need to have the area of the triangle. We need to have the other actually angle, and also the other actually sides of the triangle. So how should you have it? So in this case, this is 7 centimeter. By the way, you should have a 7 centimeter. So in this case, we have 7 centimeter and its opposite angle. We have this angle, and we do not have its opposite side. So that's the beginning of everything. Or else, we have the other two angles. We can be able to find this angle using using the theory of angle sum of triangle. Whatever the way, let's just have to start looking at this angle first. So we have the angle Q, and plus the angle should be Y, plus the angle R, which is equal to 180 degrees. And reason being angle sum of triangle. So don't forget expressing the reason behind. So we have 43 degrees plus, what is the actually a Y, that is 71 degrees, and a plus angle R, so which is equal to 180 degrees. So what is the angle R? It is given as, should be 71 here. We have 180 degrees minus, so what is the sum of 43? Should be, what is the sum of 43? Plus 71. So which is 144. So have 180 minus 144. Should be 114 degrees. So angle R is given as 180. So should be 180 minus 114. That is given as the 66 degrees. So which means the angle R is given as 66 degrees. Like that. And now we can be able to have, let's say, the value of this side and also this side, either using the cosine rule as well as the sine rule. But what I want is that you should have this side and also this side using the cosine rule. Can you specifically use the cosine rule? And also from there, you should have the area of the triangle. So try to have that. And also at your own time, try to go through the following and appreciate how you can have that one. Let's say we have, let's say we have let's say we have the information that there is a triangle ABC. Let's say in the triangle ABC, and given that we have the side AC, which is given as 7 centimeter, and we have the value of the side BC, which is given as, and that should be 5 centimeter. And let's say we have the angle ABC, which is given as 55 degrees, like that. Now, we wish to have the values of the side AB and also the value of the angle, that is ACB. How should we have it? And let's say we also have the triangle. Let's say we have the triangle ABC, and in the triangle ABC, we have the angle, let's say B, that is being given as 49 degrees, and we have the value of the angle C, which is given as 62 degrees, and we have the value of the side B, which is 20 centimeter, and we need to find the value of the angle C. What is the value of the angle C if that is the case? So try to have those, and also you need to have their corresponding areas of the triangles. So you should have to calculate the areas of the triangles as well. And let's say we have the triangle, let's say the triangle, XYZ, and such that we have the angle X, which is given as 36 degrees, and we have the side labeled X, which is 12 centimeter, and we have the side labeled Z, which is 14 centimeter. So the question says that we should have the value of the angle Z. So how should you have that? So try to express that, and also you should have to calculate the area of the triangle as well. And also let's see how we can have the following as well. Let's say we have the triangle given as a triangle ABC, and such that we have the value of the angle A, which is given as the 71 degrees, and we have the sides, side AC, we have it as 9 centimeter, and we have the value. Now in this case, we have the value of the side AB. Let's say it is given as 7 centimeter. Then we should have to calculate the value of the side BC. So how do you think you can have that? And also find the area of the triangle. So by the way, if you wish, you can just have to, find everything which is missing with the triangle, and for you to mastermind the concept. And also, let's say we have this kind of a triangle, that is, let's say this is the triangle that we have. Let's say this is the triangle, where this is the triangle A, B, let's say C, and this is, let's say, 120 degrees, and this is, let's say, 10 centimeter, and let's say this is given as 14 centimeter. So we should find the area of the triangle and everything which is missing. So how should you have that? And try to express that. And also, let's say if we can have something like this, and let's say we have just this information. Let's say we have the triangle ABC, and such that we have the side AB, which is given as 14 centimeter, and we have the side BC, which is being given as 12 centimeter, and we have the side AC, which is being given as, let's say, 20 centimeter. Then now we should find the value of the angle, let's say angle ABC. So how should you have that one? And you try to have that with at your own time. So in case you come across, in case these things will be difficult for you, please come forward and they will help each other. So let's say now how about, let's say, if we have this case. Now all I want is that now you should have to try this question at your own time. And where you come across the problems, don't forget to DM me, then we'll be able to discuss about. And these videos, you can find them on the TikTok, Instagram, as well as the YouTube channel, and all given as GP Analytical School of Science. So you come across all these things. Let's say that is a 16 centimeter, like that. You have, this is A, this is D, B, let's say this is C. So in this case, assuming that A, B, C, D, A, B, C, D, it is a parallelogram. If that is the case, then it means this actual side, it is parallel to this side, and likewise, we'll have those, because it is the parallelogram. And let's say the angle BAT, angle BAT, that is the angle BAD, it is given as 60 degrees. Now the question says that we should have to calculate the area of the parallelogram. Has to be expressed in sides. So we should calculate the area of the parallelogram and to be expressed in sides. So try to have that with your friends and discuss about, that is how we can make it as so easy. So we need to consult with your friends and discuss and solve some questions, and you become a star upon sharing the information with your friends. And also try to have this and see how you can have, let's say this is angle 60 degrees, like that, and this is, let's say, 12 centimeter. So we should have, now let's say if we have the area of the triangle being given as, let's say, 16 square of, let's say, 7 centimeter square. Now if that is the case, then what is the value of the side AB? Let's say this is ABC. So if the area of the triangle is given as this, what is the value of the side AB? So try to have that at your own time. And also let's appreciate this one as well, if we can make it up. Let's say we have the triangle. That should be this. Let's say we have the triangle, something like this. Let's say this is the triangle we can have. Let's say this is 5 centimeter, and this is, let's say, 15 centimeter, and this is the angle 120 degrees. So it is given as BA, let's say C. So we should have to calculate the area of the triangle. So this is how you should have to understand about the trigonometry part 2, where you need to understand about the cosine law, sine law, as well as the area law. And next we're going to apply this in what we call as the bearing. That's the knowledge you need to understand before you go for the bearing concept. So practice makes perfect, and try to practice more, come across different questions and different orientations, then you become a star for this. Thank you. And these videos and more videos are available in all platforms, titled GP Analytical School of Science, where you come across everything to do with science. Thank you.